The GFL-1500 has several different functions. The first one is analyze. Analyze measures voltage between the positive and the negative of our string of PV modules to measure open circuit voltage. It will then measure from positive to ground and negative to ground and check for voltage there. If it identifies voltage between either the positive to the ground or negative to ground, it will also give an estimated range of the resistance in the ground fault. Analyze mode, if you enter the number of modules in the string, will also tell you the approximate location of a ground fault. It does this by dividing the number of modules by the open circuit voltage to identify the open circuit voltage of the individual module. And then when it detects voltage to ground on either the positive or negative side, it divides by that open circuit of the individual module to identify the approximate location in the string of that ground fault. Analyze mode will return 4 different possible results. The first one is a hard ground fault. This is a fault that has low resistance to ground, so it's typically would be a solid ground fault where there is a permanent connection to the ground that is always present. This is one of the easiest ones to find because of that low resistance to ground. The next one would be no fault found, where there is no voltage found to ground. That would indicate that there is no ground fault in that section of the array. Another one would be a high resistance fault, and this is a fault where there is high resistance to ground. These can be more challenging to locate when you get into the tracing modes, so you may need to adjust your workflow based on that resistance to ground. The final result is high resistance and capacitance, and this is kind of an inconclusive result, and it happens when you have high capacitance to ground. These may indicate that there is no ground fault, but there is a chance that there could be an intermittent ground fault if you get that result. Depending on which result you get will identify what workflow you'll use when you move to the next function, which would be the fault function, where you would trace the fault using either the current clamp or the receiver.